Oh my god, it's a cable router. SMC Networks, DOCSIS 3.0, 2010-ish. Let's get in it. Well, I don't even know. This is more boring than I even thought it was going to be. What do you expect? Anything? Anything? Oh, I felt a bump. I felt one thing. Pretty smooth over here. Oh, Jesus. Wow. So this is all lead free. So I could either crank the gun up here, I could give that a try, but what I'm going to try is go through here, flux this up here, and just put a bunch of regular good old leaded solder all over the place and see how that fares. Alright, let's go after this barrel jack. Got it. Alright, I'm going to try this crystal here now. Oh, Jesus. Finally. Holy crap. No, no good. Fuck. No, wait. What the hell? Is that the pad? I can't see under there. That's a piece of shit. I hate this thing. There we are. This is a flash memory chip right here, S25FL. And in itself, you know, it's not horribly exciting, but it is a flash memory chip. And it's sitting around these other devices, so I start taking a look around a little bit more. Later, I did desolder these things, but it was a horrible mess, so it's not actually part of the video. So there's no room to talk about it there. So right here, this is a Texas Instrument BGA. I can't find an actual data sheet on this. It does, from some things, appear to be a purpose-built chip for DOCSIS cable modems. This over here, this Nanya chip, this is your memory. So over here, this is the 512 megabyte DDR2 RAM. And you can see that it's in heavy communication with this chip over here. And if you flip it over to the back side, you can see even more traces there. So that's kind of interesting. So this is talking to this. And then I suspect, from what I have heard, the flash memory is over here for storage, or possibly keeping information inside of it, so when this boots up, this tells this what to do, because this might not have any internal flash memory. I guess. I don't know. I've heard FPGAs utilizing that a lot. Then the other thing I wanted to point out is something that I found interesting, since it was right here in front of my face. This idea of a differential pair, and the differential pair is a cool idea, kind of like the twisted pair in Ethernet cable, to either, you know, stop any kind of crosstalk from happening. So that's most likely what you're seeing in these match sets right here, or cause a delay in the timing of certain things. So if you have a couple different clocks coming out of your clock cycles, and they're hitting lines with a clock on them going into some other device here, and the signal is arriving, but the clocks are out of sync a little bit, by skewing these, by bending these a little bit, you skew the clock. So that's what's happening there, and that's actually the term. Skew is when the clocks become, not synced together so well. So they actually just take the lines and make them a little bit longer or a little bit shorter so they match up when they get to here. Alright, so that worked out pretty good. It's a bit of a pain in the ass, but if I really wanted this little chip right here, or I wanted it off of there and was going to do a repair, I guess I can get this to work. I'm having some more success with this here. I just gotta be patient. So it's kind of like it's coming up, starts to come, and then it just sort of rips away. Then I can get underneath of it. It seems like the pad is still there. And then I've been just kind of running it over and figure, yeah, it kind of melts, so I figure that's the solder on the pad. This chip that I'm about to take off is an FP6 101 that you can see over here, and so this is your switching regulator, and so that's fine. That's what it is. I actually even found the right company here from Feeling Technologies. Look at that. But what I wanted to talk about was the typical application circuit that you see in all the data sheets. So I've been seeing a lot of these lately. I've been looking and studying a lot of these lately for, I'm doing little things like maybe trying to make a board, but it's one of those boards that you can buy for like $4 from Adafruit or SparkFun, but I want to do it myself, or I want to incorporate it into a PCB that I'm making. So I need to go to the data sheet and I need to look at the typical application circuit. Well, after looking at these typical application circuits and then looking at other people's parts that they've made, lo and behold, most of these people damn near verbatim copy the application circuit. So you look over here, you see this Feeling Technology here, you got this right here, and here is the chippy right there. And then if you look, this one right here is an SK24A, which is a Schottky rectifier. And if you look over here, here is your Schottky diode. And it's reverse biased against this over here. But let me bring this up real fast and then I can explain that as well. So now let's see if I can recite this out here, because I've been studying it and looking at it off camera. And so what I want to show you here is that in a little bit more detail, as much as I can suss out of this, you look at this part right here, and here's your application circuit, here's your Schottky diode right here, and so then you're looking over here and you see these pins. Sorry for being upside down, but over here is ground, and it says, okay, that pin over here is ground. See, look at, you can see the logo right here, and pin 1 is over here. And then this one is supposedly also ground, and if you look up here, sure enough, they're both on this big flood zone over here, which is probably ground. So then you look over here, and here's LX, and LX has to do with the PMOS, which I forgot what that stands for, but I'll get past that for right now. So they're both over here on LX, and so does LX run into the Schottky diode in the reverse bias? So if you come over here, here's LX and LX, and sure enough, they both smash right into the wrong side of the Schottky diode. So hey, that looks pretty cool. And then the other side over here of this goes straight into ground, which I'm assuming zips underneath here and probably goes somewhere else. Then, if you continue to look around, I can't see quite how it gets here, but odds are that's going to be the inductor right here. And then these caps, you can see here's one off of VCC. They're not electrolytic. Maybe that's what these were supposed to be right here. Matter of fact, now that I just noticed it, maybe they were going to use this and decided they didn't need it. And let's see, so then a couple others coming out of SCC. So I don't see that one right here. I see one coming out of just these ones out of VCC. So anyways, so those ones I can imagine how they would come and go as they want to tune it, I guess might be the right word. So I think this is pretty cool. I think this is kind of a little bit of a a key to finding out a lot of this stuff. And if anything, from this whole like stupid ass cable modem video, this was maybe something cool that I got out of this. So I'm going to go ahead and call it there. This board is kind of bugged me enough. There really wasn't a whole lot going on, and with everything lead solder and me, dinking around with the solder rework station and the solder sucker, it just wasn't that fun to do, but it's a cool learning experience. I know that lead-free solder is used everywhere. I guess I just wasn't really expecting to run into it here. I was hoping that it was going to be yippee yay, I'm going to grab a new device and it's going to be a quick neat little teardown like it was with the power supply, but whatever. It wasn't that. I'm on the lookout for a couple more devices to see what's going to be the next one. I have a few ideas. Actually, I got a whole room full of crap. I guess it's just I want to make sure we don't run into another one of these, at least so soon. So anyways, thanks everyone for watching. I will see you next episode.